The topic of the month for June 2018 is transition training. In this presentation, we'll talk a little bit about loss of control accidents and recommendations from a work group that studies loss of control. We'll talk about the different types of transition training and offer suggestions that will help you get the most from your training. Finally, we'll give you some tips and tricks that will help you avoid loss of control in any aircraft. There were 1,250 fatal loss of control accidents in a recent 10-year period. About half of those accidents occurred in the maneuvering and approach phases of flight. Think stall, spin, crash. It's also true that many accidents occur when pilots fly aircraft with which they are unfamiliar. In fact, the first 50 to 100 hours in a new aircraft type are particularly dangerous, especially when a formal transition training program is not followed. Here are some findings of a recent study of loss of control accidents. Most fatal GA loss of control accidents have one or more of these causal factors. Single pilot cockpit resource management skills are often cited as deficient. There's a lot of information and resources available, and the most successful pilots know how to make use of all of it without introducing distractions. Many loss of control accidents result from unstabilized approaches, both VFR and IFR. This is closely tied to the next item on the list, go-around procedures. If you're not stable on final approach, go around. Don't give in to the pressure to get it on the ground. Learn to recognize and correct for destabilizing influences. For flight after extended periods of not flying, think of aircraft builders who spend years of spare time building and then begin a flight test program in a brand new aircraft. Or imagine a pilot who's taken time off from flying to work on career, education, or family, and then returns to the game. Transition and refresher can make all the difference here. Insufficient transition training is what we're addressing in this presentation. So, enough said about that for now. We're seeing in the airlines and also in general aviation, over-reliance on automation and the proliferation of glass cockpits have contributed to a remarkable number of loss of control accidents. Toxicology studies following fatal GA accidents found some sort of medication in 80% of accident pilots. Although we can't say the medication caused the accident, it could be a factor, as is the underlying medical condition requiring the medication. Obviously, full disclosure to your aviation medical examiner is key to avoiding compromise of your piloting skills. Finally, investigators suggest the need for improvement in aeronautical decision making. Pilots usually think of transition training in the context of stepping up to a larger, faster, or more complex aircraft. Transitioning pilots are not accustomed to complex airplanes, which are generally faster than what they usually fly. With more to do and less time to do it, staying ahead of the airplane can be a challenge. But transition training works both ways. Believe it or not, it's equally challenging to transition from high-performance airplanes to lower-performance aircraft. Pilots trained in C-152 Heavies approaching a 60 knots may find themselves floating down the runway in designs with lower wing loading and lower approach speeds. Stories abound of light sport aircraft damaged at the hands of certificated pilots who were trained in traditional aircraft. So stepping down is just as important as stepping up. Let's face it, we all want to get the best performance out of our flying machines, and we want to do it safely. That means we need to be thoroughly familiar with each aircraft we fly. Well, it's obvious that the need for transition training isn't going away soon. Now, let's take a look at how to get started. What types of aircraft do you fly? You can get a leg up on your transition if you study the book first, especially if you've flown similar aircraft before. If the systems are all new to you, get a flight instructor to guide your study. Know these cold: emergency procedures, speeds, power settings, and configurations for normal operations. Plan several flights that represent the types of operations you intend to pursue. You'll get a feel for what you can and can't do with the new flying machine. As you progress, keep a list of questions and review them with your CFI. Finding the right flight instructor is key. Your CFI may be experienced and current in the make and model to which you are transitioning. To find the right instructor, interview current owners. They can recommend training organizations and flight instructors, and they may be willing to loan you some training materials to review. Aircraft type clubs are an excellent source of aircraft-specific information. Many maintain rosters of CFIs and can often get you discounts on insurance. Pilot organizations may refer you to training providers and owners. Simulation training providers, expensive but worth it, especially if you're new to high-performance aircraft, may be required to qualify for insurance. Use a syllabus. Effective transition training conforms to a syllabus, a roadmap through the instructional process. A good syllabus will contain training events and schedules, satisfactory completion standards, instructor and student roles and responsibilities. Instructors should share their syllabi with their students. That way, both know what needs to be done, when it needs to be done, and what success looks like. Budget your time and money. Plan for a regular training schedule. Many instructors recommend no less than 2 training periods per week. Progress is slower and information retention is reduced if you stretch out your training. Simulation training providers usually plan transitions for a week of training. It's a good idea to interview more than one flight instructor. During the pre-employment interviews, you'll want to accurately inform CFIs of your experience and capabilities. Discuss the aircraft you've flown and ask for input on your planned transition. Be sure to clearly state what you expect to get out of the training and how you intend to use the aircraft. This is also the time for CFIs to tell you about their flying. Overall experience is always valuable, but more important is recent experience in your aircraft and operations. Also assess the CFI's communication style. Is information conveyed clearly and without ambiguity? Is the candidate an effective teacher? Amateur-built and light sport aircraft have a huge range of flight characteristics and performance. Cruise speeds from less than 60 to more than 300 miles per hour. High wing loading can result in higher stall and approach speeds. Low wing loading can result in excessive float if approach and landing speed is too high. Structure may not be as crashworthy as standard type certificated designs. May have comprehensive or minimal POH. Amateur-built aircraft in particular may vary from airframe to airframe, even with the same make, model, and series. Construction differences abound. Builders often modify design during construction, often feature non-standard placement of instruments and controls. Builders develop their POH during the flight test phase of the project. Some POHs are comprehensive, some are minimal. Another reason why instructor selection is critical. Light sport aircraft come in many forms, including airplanes, gliders, powered parachutes, weight shift control, and lighter-than-air designs. LSAs are manufacturer-built to LSA consensus standards and are issued a special airworthiness certificate and standard operating limitations. Owners and operators are required to maintain these aircraft according to manufacturer's specifications. ELSAs are either amateur-built or may have been moved to the ELSA category by their owners. They are issued experimental airworthiness certificates and operating limitations appropriate to the individual airframe. Obviously, transitioning pilots will need to know what type of certificate and operating limitations pertain to the airframe they're flying. Another good argument for engaging a CFI who's thoroughly familiar with the nuances of the flying machine and who could explain the paperwork to transitioning pilots. Background. In 2012, NTSB completed a safety study of EAB aircraft that included the use of an EAA survey of EAB pilots. Among other findings, NTSB concluded that the flight test period, the first 50 hours of the flight, is uniquely challenging for most EAB pilots because they must learn to manage the handling characteristics of an unfamiliar aircraft while also managing the challenges of the flight test environment, including instrumentation that's not yet calibrated, controls that may need adjustments, and possible malfunctions or adverse handling characteristics. NTSB added that the EAB safety record could be improved by providing pilots with additional training resources and, accordingly, made several recommendations to FAA and EAA regarding flight training and testing. Here we can see that fatal accidents in amateur-built aircraft occur at more than twice the rate for standard aircraft. The first 50 hours in experimental amateur-built aircraft are particularly hazardous. Constructors must conduct a test flight program to develop performance and control parameters, and, based on those test flights, adjustments and modifications may be required, all while learning how to fly a new aircraft. Constructors use the test flight data to produce a pilot's operating handbook that may be comprehensive or minimal. At least future pilots of that aircraft with access to the POH will have something to go on, but for the original constructor, it's all new territory. Many amateur-built aircraft are faster and less crashworthy than standard aircraft. They often have higher stall speeds and different handling characteristics, but of special interest in the transition discussion is that pilots trained in standard aircraft and who are certificated at the private pilot or higher level are more than twice as likely to crash a light sport aircraft than LSA pilots who were initially trained in light sport aircraft. Skills learned in standard aircraft don't directly translate to LSA operation, lower aircraft performance issues, lower wing loading. Some transitions require documented training and/or additional certification. Tailwheel, complex, high-performance, and high-altitude operations require training and an endorsement. Multi-engine and seaplanes require training, endorsement, and a certification test. Whether or not you'll be taking a flight test, it's always important to get the right instructor, one who's not only thoroughly familiar with the airplane, but also with the environment where you intend to fly. Obviously, getting your tailwheel endorsement at a 3,000-foot paved airport in Florida won't prepare you for off-airport operations in Alaska. Work with your instructor during your training to develop personal performance figures and personal minimums. This will tell you what you're capable of doing with the aircraft in your chosen operations environment. We suggest you revise the data you develop annually. That way you'll know exactly what you're capable of and what you're not. Make sure you do some training and develop your personal performance data at mission weights. There's often a big difference in performance and handling between a fully loaded aircraft and one that only hauls a couple of people and half fuel. Remember, there can be a big difference between being legal and being safe. You might get your high-performance training in a Cessna 182 and your tailwheel endorsement in a Piper Cub, but that doesn't mean you'll be safe in a Cessna 195 without some additional training. New avionics systems also require transition training, not just to get the most out of them, but for basic safety as well. Many transitioning pilots feel overwhelmed by the volume of information available on today's avionics systems, including trouble separating critical information from non-critical, confusion over multiple ways to do the same thing, soft keys that can represent multiple functions, and increased heads down time. What sort of instruments are you flying? Expect transitions to take longer if the aircraft you're training in has unfamiliar glass cockpit instrumentation. You can reduce training time and make time in the aircraft more productive if you log some time on an avionics simulator. Most manufacturers have personal computer-based simulations for their product. Many avionics packages can be operated in simulator mode. Big changes in operations environments should also be viewed as transitions. Private pilots must be trained and tested on towered operations, but it's a good idea to take a CFI along on your first trip to a major metropolitan area. A private pilot with less than 50 hours in type crashed on final approach while complying with a series of controller requests for S-turns to accommodate departing traffic. Never compromise a stabilized approach by maneuvering. If maneuvering is requested or required, go around. Similarly, requests for speed changes should not be honored if they would result in a destabilized approach. Big city pilots who are comfortable with busy towered operations can be overwhelmed when operating to backcountry airstrips. Backcountry transition training can acquaint you with the nuances of rural environments and ensure your wilderness flying can be done safely. Finally, here are some tips and tricks to help you avoid a loss of control accident. Give yourself some room. Most stall spin crash sequences begin close to the ground. Many happen in the traffic pattern. So, when you're thinking about going slow, don't think low at the same time. Practice slow speed maneuvering at altitude where you have time to recover from a stall or a spin. Do this regularly to maintain proficiency. Manage distractions. Learn to manage distractions, especially while maneuvering close to the ground. Sterile cockpit while in departure and approach flight segments and while maneuvering. Make sure aircraft is stable before copying ATC instructions, changing charts, reviewing approach, etc. Assign a second pilot or passenger to help you scan for traffic. How do you manage distractions? Fly by, not around. When viewing scenery or photographing subjects on the ground, fly by your target in straight and level flight, then turn and fly by in the opposite direction. Concentrate on the mission task while stable, then concentrate on the turn. This is also a good time to have a second pilot aboard to share the workload. Document your personal performance. Do this at mission weight and in the environment you'll be operating in. This will tell you what you're capable of doing with the aircraft. Seek regular refresher training. Even though your transition training was excellent, regular proficiency training will keep you at the top of your game. We recommend a refresher within 6 months of your original transition training and an annual checkup after that. The Wings Pilot Proficiency Program is an excellent way to keep your skills sharp and your flight review up to date. And finally, practice. It's amazing how quickly pilot skills can go from razor sharp to not so hot. Regular practice is essential to keep you at the top of your game, so fly as often as you can. You'll aviate with confidence, and besides, it's fun. Now for a quick review. Blank and blank together account for about half of all fatal LOC accidents. About half of all fatal LOC accidents occur in the maneuvering flight and approach phases of flight. Answer this question. To get the most out of transition training, D. All of the above. True or false? Transition training is more important when stepping up than when stepping down. False. Transition training is important whenever you're operating an unfamiliar aircraft or avionics system, as well as when you're operating in unfamiliar environments. Pilots trained in traditional aircraft are more likely, less likely, or neither more nor less likely to crash in LSAs than pilots trained in LSAs to begin with, and what's to be done about it? The answer is more. Good practices to avoid loss of control are A. Avoid distractions. B. Seek refresher training. C. Fly by, not around. D. Practice slow maneuvering at altitude. E. Participate in wings. Or F. All of the above. The correct answer is F. All of the above. Please direct any questions to your local FAST team representative. Narration by Bradford Wood, Assistant National Outreach Manager. There's nothing like the feeling you get when you know you're playing your A game, and in order to do that, you need a good coach. So fly regularly with a CFI who will challenge you to review what you know, explore new horizons, and to always do your best. Of course, you'll have to dedicate time and money to your proficiency program, but it's well worth it for the peace of mind that comes with confidence. Vince Lombardi, the famous football coach, said, "Practice does not make perfect. Only perfect practice makes perfect." For pilots, that means flying with precision, on course, on altitude, on speed, all the time. Be sure to document your achievement in the Wings Proficiency Program. It's a great way to stay on top of your game and keep your flight review current. Your presence here shows that you are a vital member of our general aviation safety community. The high standards you keep and the examples you set are a great credit to you and to GA. Thank you for attending.